So now we start some calculation business in the phase diagrams. What you see is the lever rule. The lever rule. It gives the weight percent of phases in any two-phase regions. And weight percent is just an old terminology. Actually, it is mass fraction, right? But earlier, mass and weight used to be the same thing. Even today, when you say, somebody asks you what is your mass, I mean, actually they say what is your weight, and you give your weight in kilogram. You don't give it in newtons. So in general language, mass and weight are interchangeable. So this is actually mass fraction, but we call it weight percent. And this whole diagram that at any given composition or weight fraction, right, any composition, and at any given temperature, you have mixed phase, liquid and solid. So how much of the liquid is there and how much of the solid is there? This is lever rule. Last time, and we told you that we will start this new lecture with lever rule. Very quickly, if I sum up, in a phase diagram, we will always give you the phase diagram, and we will give you the composition of the alloy at which we want to find something. For example, here the composition is W0, the weight percent. Actually, I have told you, right, it is mass percent, but we will call it weight percent. So we will give you the weight percent original, and we will give you a temperature at which to find out things. So the phase diagram will be given, initial composition will be given, and an initial temperature will be given. And what were the questions that we discussed last time? At this temperature and at this composition of the alloy, what are the phases present? Only liquid, only solid, or liquid and solid? If they are liquid and solid, then what is the composition of the liquid phase and what is the composition of the solid phase? Today we find out that at this given initial composition W0 and a given temperature T, what is the mass fraction of the liquid and the solid? This is not composition, this is mass fraction. So if you see weight fraction, mass fraction, whatever you write, if we want to find for the solid, you see you have drawn the tie line. You have drawn the tie line. This L is the liquid point, O is the original point, and S is the solid point. So if you want to find the mass fraction of the solid, you see, you want to find the mass fraction of the solid, you go to the opposite side of the tie line, this side, the length LO divided by the total length LS. Length LO is what? W0 minus WL, right? So W0 minus WL. Total length is what? WS minus WL. So this is the formula. So this is a very, very simple rule. Whenever you want to find the mass fraction of the solid or the liquid phase, if it is the solid, you go to the liquid side and find the length. If you are finding for the liquid, right, you want to find the weight or mass percent of the liquid, go to the other side. So it will be WS minus W0. WS minus W0 upon the total length, which will always be WS minus WL. Right? So it's a very simple rule. It's called the lever rule, either because there is a lever and there is a fulcrum, or because the scientist who started finding it was Mr. Lever. Right? So we have done the third step in the phase diagrams. First thing, what phases are present? Second thing, what are the compositions of the two phases? And third thing, what is the mass fraction? Right? Let us move on. Now, as we do earlier, we will take an example and we will do it interactively. So you can see that this is the diagram given to you, right? And you are saying that the tie line is there. It connects the phases, right? The tie line has been drawn. You see the tie line, right? And if you see as a lever here, then mass fraction of liquid, mass fraction of alpha phase or solid phase. And then you just do it. Mass of liquid is solid minus original, and mass of solid is original minus liquid, right? The same thing. For solid, go to this side, divided by total length.
For liquid, go to the other side, divided by the total. So we have recapped it for you so that it becomes important. So we are just doing the same thing here. We have talked of phase diagrams. There is a temperature, there is an initial concentration. In this slide, we are using C for concentration. In our book, we are using W, and so on and so forth. So, but this is the same thing. This is the same thing. This is a copper nickel diagram. You have done it. So let us go ahead, right? We are doing this. So let us take an example now. The example will pop up. The example is that we want to find at 1100 Celsius. At 1100 Celsius. So, right? So if we start with a 60 weight percent, right? 60 weight percent alloy, then of course we draw a vertical line all the way, vertical line. Now if the question is 1100 Celsius, at 1100 draw the horizontal line, see where it is all solid. So there will be only alpha phase. So that is what we are saying, there will be only alpha phase at this temperature. Another example, take a 35 weight percent alloy and take a temperature of 1250 Celsius. So 35, right? This is 20, 30, 35, draw a vertical line. And then see 1250. If it is 1250, you go horizontal line, it is inside. Inside means it is liquid and solid. So there is liquid phase and alpha solid phase, right? So at 1250 Celsius, there will be liquid phase and alpha phase. That is, we do. Let us take another example. We are doing the same alloy system, copper nickel alloy system, but now we say let us take the original composition as 35 weight percent nickel. So if we do 35 weight percent nickel, at 35 we draw a vertical line. Next step, what is the question? Find at 1320 Celsius, right? So at 1320 Celsius, draw a line. So what do you get? Everything is totally liquid. So what will be your answer? Only one phase, liquid phase. So there will be only one phase, liquid phase, only one. And what will be the composition of this liquid phase? Because there are no two things, there is only one point. So the composition is the original composition, 35 weight percent nickel. Of course, if you remember, when you write 35 weight percent nickel, you can write a comma and 65 weight percent copper. So that will be the total answer, right? So if your initial composition was 35, if your temperature was 1320 degrees, then there is only one phase, the liquid phase, and whenever there is only one phase, the composition is the same as the original composition. Now let us take the same example, but at 1190 Celsius. So now it will be only solid phase alpha, so that would be the answer. And again, because it is only one phase, therefore the composition remains the same as the original composition, 35 weight percent nickel. Now let us take that example where there will be two phases. We take the temperature of 1250 Celsius. So we go inside, it means it is liquid and solid alpha, Once it is liquid and solid alpha, we will have to draw a tie line here and then find the compositions, right? If it was only one solid liquid phase or only one solid phase, the composition is the same. But if there are two phases here, then we have to draw a tie line so that we cut the liquid phase and we cut the solid phase. So that is what will be done. There will be both alpha and liquid, and to find it, we will have to have the tie line. So now we have the tie line, we will have to draw a vertical line here to find the composition of the liquid phase. We will have to draw a vertical line here to find the composition of the solid phase, right? So that is what interactively is being done. If we draw this line, then we find 32 weight percent nickel. So the composition of the liquid phase at the temperature of 1250 is 32 weight percent nickel. Let us proceed. For the solid, right? For the solid, we draw this line. So it is, if we read 43, of course, when you are reading it, you can read it as 43, you can read it 42.5. You can be wrong by 0.5%, but you can't be wrong by 2-3%. Then you are not reading correctly. So at the given temperature of 1250 Celsius, there are two phases. The liquid phase has a composition of 32 weight percent nickel, and the solid phase has a composition of 43 weight percent nickel. This is what we are showing you here in this slide, right? So we are doing the example many times, just so that you get very much used to it, right? And of course, in your video presentation, you can go back and forth. You can stop for some time and go further and so forth. So now just proceed further. Now remember, right, that our question always is that we have given you an initial starting composition which is 35% nickel. We can give you any temperature, this one or this one or this one. Right now we are giving the temperature of 1250 and so on. So there were three questions. The first question was, at this point, how many phases are there and what are they? So there is liquid phase and solid alpha phase. Second question, what is the composition of the solid and liquid phase? So you draw a tile line and you find the composition of the liquid phase, you find the composition of the solid phase. Third question, at this temperature and this composition, what is the mass fraction or what is the weight fraction of the two, right? So this is what we want to do now. So, right, so we are just repeating everything that we did earlier, we are repeating, but for the mass fraction, right? Now for the mass fraction, if you want the mass fraction of the liquid phase, go to the opposite side of the tie line, find the length of this side, which is, right, which is solid minus original, right? So solid minus original. So this is 43 minus 35, 43 minus 35. And the total length is of course 43 minus 32. So 43 minus 32. Now once you find that this is roughly 73%, you already know 100 minus this will be the other one. But don't do that. I would always recommend that when you find for the solid, you say go to the opposite side. It is 35 minus 32. So write 35 minus 32 divided by 43 minus 32. If you get 27% roughly, then you are confirmed that your previous one was also right. But if your two answers do not add to 100%, then there is an error. Of course, when you round off, it could be 99.1%, 99.9%, it could be 100.5%. So that very small error is okay. But you cannot get 98% or 99% as the total. You cannot get 101 or 102%. Very close to 100%, right? So we have done it now so many times so that you are very solid. There is only one equation, right? The lever rule. Otherwise things, just draw a vertical line, just draw a horizontal line, just draw a tie line and then go ahead.